Okay, good morning class. So today we're looking at number patterns. We're looking at the examples for exercise, or the example for exercise 3.2 on page 72. There's only one of these, so I'll take one out of the exercise as well. So for the quadratic sequence, the general term of quadratic sequence is written as Tn is equal to an squared plus bn plus c. This should remind you of your parabola equation, not so, which is y is equal to ax squared plus bx plus c. Okay, or a trinomial, which is ax squared plus bx plus c. Or a quadratic equation, which is ax squared plus bx plus c equals 0. That's the standard form of a quadratic formula or a quadratic equation there. Where n is given as the position of the term in the sequence, and of course Tn is your general term. Right, so we're looking at question 1. Question 1 is on, example 1 is on page 72. The question says you got Tn is equal to n squared plus n minus 3. So you are given the general term now. The general term is given. The first question says write down the first 6 terms of the sequence. The first 6 terms. So if Tn is equal to n squared plus n minus 3, the first 6 terms, where n is 1. Term 1 is 1 squared plus 1 minus 3, which is negative 1. Term 2, where n is now 2. 2 squared plus 2 minus 3 is 4 plus 2 is 6 minus 3 is 3. Term 3 is going to give us 3 squared, which is 9, plus 3 is 12 minus 3 is 9. Term 4 is 4 squared, which is 16, plus 4 is 20 minus 3 is 17. Term 5. So wherever I see an n, I replace this with the position number now. So 5 squared is 25 plus 5 is 50, and 30, sorry, minus 3 is 27. Term 6 is the 6th term, of course. Going to be 6 squared is 36 plus 6 is 42, minus 3 is 39. Okay. Is there any confusion there thus far? Did I make a mistake in here? So it's 4, 6, 8. No. 1, 3, 9, 17, 27, and 39. Okay. You all agree with that, people? Let's look at B. The B part of the question says, calculate the first and second difference between terms. So my first term, of course, is negative 1, then 3, then 9, 17, 27, 39. So if you're looking at what are they referring to the difference? People, this was arithmetic, also known as a linear, and this had a first common difference. Can you see that? This is your first difference. There's a first constant. So coming back to this here, let's work out the difference here. It's going to be 3 minus 1, which is 4. 9 minus 3 is 6. 17 minus 9, 8. 27 minus 17, 10. 39 minus 27 is? And this is your first difference. You will understand. Does it have a constant first difference? No. So let's see here. 6 minus 4, 2. 8 minus 6. What do I notice now? Now we have a second constant difference. Second difference. So when it was linear, it had a first common difference, or constant difference. When it's quadratic, it has a second constant difference. Can you see that, people? Now with that in mind, as I said, there's only one example here. I'm going to use another one out of exercise 2.3, just to solidify this explanation here, and we'll speak about that off camera, if the recording. I don't want the recordings to be too long. Okay. People, I'm looking at exercise 3.2. For the, does it do 6? Okay. I'm going to ask now which one of the 6 you want me to do. So the question was for 6. So 3n is equal to half n squared plus n plus 4. The first question says write down the first 8 terms of the sequence and calculate the first and second difference of the first and second difference in these examples. Okay. So where do we start? We work out our first 8 terms. So I start with T1. So it's going to be a half times 1 squared plus 1 plus 4, which is 5.5. You all agree with that? Term 2. It's going to be half times. N is now 2. 2 squared plus 2 plus 4. That's going to give you 4, 2, 4, 8. Is that correct?
Yes, sir.
Term 3. It's going to be a half times 3 squared, which is 9. 9 over 2 plus 2 plus 3, sorry, plus 4. So that is 7. 7 plus 9 is 4, is 11.5. Is that correct? Sorry? 11.5. Sorry?
11.5.
Is that correct?
Yes, sir.
Okay. So that's 11.5. For term 4, it's going to be half times 4 squared plus 4 plus 4. That's going to give you 16, 8. 8 plus 8 is 16. Is that correct? Term 5. It's going to be half times 5 squared plus 5 plus 4. It's 9. That is 25 is 12.5. It's 21.5. Is that correct? Check this one.
Yes.
Term 6. Correct?
Yes.
So it's going to be half times 6 squared plus 6 plus 4, which is 10. 36 plus half of that is 18. It's 28. Huh?
Yes, sir.
Right. And then term 7. It's going to be half times 7 squared plus 7 plus 4. 7 plus 4 is 11. 49 is 24. 14 so it's 24.5 plus 11. It's going to give you 35. Just check if that's correct. 35.5. And term 8. Work out term 8 for me. It will be half times 8 squared, which is 64 divided by 2. Sorry? 44. Alright, so there's your first 8 terms of the sequence. Easy, no? So now the next question says, the next part of the question says, we must work out our first and second common difference. So my first term is firstly 5, 5.5, and then 8, then 11.5, then 16, then 21.5, then 28, and so on and so on. I don't have space here, but you can carry on. So how do we get the first difference? Term 2 minus term 1, which is 2.5, not 3.5. 11.5 minus 8. 11 minus 8, that is 3.5. 16 minus 11.5. 16 minus 11.5 gives me 4.5. Not so. And then 5.5. Then 6.5. Then 7.5. Then 8.5. Does this has a first constant difference? No. What is 3.5 minus 2.5? 1. 1. 1. 1. So this has a constant second. So what do you notice again? Since it's a quadratic pattern, it has a second constant difference. Okay. So something we will discuss now is that you will note that calculating something to note at this point. You will note by calculating the first difference between successive terms of a quadratic sequence are not constant. The first difference is not constant. However, you should notice that the second difference is always 2a, which is making the second difference constant. So important to us, and what we're going to highlight at this point is that if we're looking at 2a, which is second difference, your a value of the formula is actually your second difference over 2. Okay? There are many methods to determine the general term of this quadratic sequence. Only one method has been illustrated in this chapter. To be important to us, we will be highlighting and looking out for these values here. Whatever number lies here, which is term 1, in its position you will have a plus b plus c. In this one's position you will have 3a plus b, and its position there you will have 2a. And you will work from bottom up. Okay, and you'll see now in our next lesson how we're going to work with that. Okay. So the full lesson can be found in the description box below.